Good morning, good evening, or good afternoon, depending on where you're joining us in the world today. Welcome to our hybrid, our live in studio and virtual broadcast from the Immersion Lab at MIT.nano. This is Immersed, our monthly series highlighting how immersive technologies, whether it be motion capture or AR and VR, augmented reality and virtual reality, can be used to invigorate and bring together opportunities in science and engineering and art. Today, we're joined by Robert Hupp. He is the assistant fencing coach at MIT. Along with Talis Rex and Praneeth Namburi, we'll be sharing with us today what are some of the opportunities to potentially use biofeedback and immersive simulation for sports training. This is enabled by the Immersion Lab. The Immersion Lab is a central facility at MIT, a shared resource for you. So as you're listening to today and the exciting thoughts that Rob has in terms of bringing technology to coaching, look at the technologies and imagine how it can be used for your sporting endeavor, your science endeavor, your engineering endeavor. Please ask questions as we go on the chats. We'll try to answer them in real time, but enough of the logistics. I'd like to turn it over to Rob and Praneeth and Talis. I'll put my mask back on, and gentlemen, take it away.
Thank you, Brian. Welcome, everyone. I'm Praneeth, and here we have Rob. And we're going to have this in the style of a conversation for a little bit. So, Rob, why don't you tell us why you, as a sports coach, wanted to come work with the Immersion Lab?
Well, first I watched a demo of the capability for another sport, and that got me interested because I had been thinking along some similar lines on my own, along with head coach Jarek Koniusz. One of the things that as coaches, we can measure some of the ancillaries for athletic performance. We can look at a fencer's record, touches scored in certain situations, wins versus losses against certain kinds of opponents. We can measure athleticism in terms of strength and speed, but there are some things we can't see and some evaluations we can't make, and it would be nice to have some data behind it other than our own gut reaction. And if we're good coaches, our gut reaction is pretty good, but there are some discrepancies in what we train sometimes and how we see our fencers use what we train, and having data to support maybe some new training modalities, that's what I'm looking for.
Nice. Thank you, Rob. So my next question to you is, how can fencing benefit from biological measurements and feedback? I know you already touched on that a little bit.
Yes. Well, you can measure motion of the weapon, motion of parts of the body of the fencer, measure general muscle tension, immediate contraction. We'd like to look at force applied to the ground. And now a lot of this has been done, but it's been done in sort of a petri dish mentality as opposed to in situ. And it's also not been integrated. You know, there are studies of speed of the point, speed of the core, plyometric studies for explosiveness.
So perhaps like an integrative theory of coaching and something that's verified and backed up by data.
Yes, and the data that's each piece is linked to another piece. We'd like to have it in real time.
Yeah.
And that's something that we can get these component measurements, and plenty of studies have been done, but having them integrated and having them what I would like to call phase locked is something that's not been done. And now we have the technology that we can phase lock these measurements.
Right. So different types of measurements, the video, the motion capture, the force and myography information, phase lock all of them, see what's happening inside the body, so to speak, when we see what's happening from the outside.
Yes.
Yeah. Cool. Thank you. So over the past few weeks and months, we've been talking about a strategy for starting a collaboration, and the strategy that we came up with was to capture the movements of more experienced fencers and use the captured movements to train less experienced fencers, and finally monitor learning in fencers. So today's overview for today's talk is going to be, Thales is going to introduce Immersive Technologies if you're not already familiar with them. And then we'll talk a little bit about our approach to sports training, and we'll do a live demonstration of a biofeedback system towards the end. So right now, I'm going to turn it over to Thales, who will introduce you to some of the technologies that we're going to use in this project.
Hello, everybody. So I'm going to explain a little bit about the immersive technologies that we have incorporated into this project to really make all of this happen. There's quite a bit of pieces in here, so I'm going to be talking a little bit about the hardware as well as the software that's kind of involved for this project. So first runner-up is the motion tracking system. So we use our OptiTrack and combined with our Motive software to allow to track these targets that we put on the body or the sword. So I'm going to play a little bit of a video here where you can actually see how these patterns are expressed in a 3D world. And with the system, we're actually able to track every single point that we mark and get a lot of data based on how they are moving with 6 degrees of freedom within this kind of the physical world. So on the left here, you see these traces. So these are how the targets are actually moving within space over time. And on the right here, you can actually see the points on the body and on the sword where we can actually target them and pull out that data. The next is a 360 camera. We use this for our virtual reality simulation, and we can actually take and capture around 4K resolution image data and being able to transfer that into a virtual reality environment. So on the left, you just see the camera that we use. This is the Theta. This is pretty simple to use. And on the right, you actually have a visualization of what they see in the virtual reality environment. And so this isn't a developed virtual assets, this is real world video. So I can play a little bit here, and you can implement user UI elements within the 3D world to actually add some more integration within the experience. And we'll explain a little bit more about the data that we're able to extract using these videos as well a little later in the talk. And for those who don't know, I just want to kind of give you an overview of virtual reality and augmented reality. So virtual reality is a complete virtual experience that fully immerses the user in a fully artificial digital environment. You find a lot of these in kind of the consumer-friendly or the consumer-based products like Oculus Quest and HTC Vive. And we actually use these hardware solutions for this project in itself. So on the left, you have that Oculus Quest 2. This involves the inside-out tracking. So you actually don't need external hubs to track you. You actually have cameras on the inside of the headset that are essentially designate your playing area. And on the right, you have the HTC Vive Pro, which has external cameras. They have the controllers as well. But what we actually utilize, and we'll show a little bit later on, is this Vive Pro has eye tracking. And we really want to bring that out in this project as well, given what we want to find when fencers, what they're looking at, and maybe more importantly, what they're not looking at. And on the right is this augmented reality. This overlays virtual objects on top of the real world environment. So you're not restricted in that sense where you are completely lost in the real world. You still have an overlay, so you can still see where you are physically within the world. And for this, we use the HoloLens 2. And you'll see, again, more examples, and we'll be doing a live demo with the HoloLens 2 later on in the series as well. And just some of the software solutions that we ended up doing for this project. The game engine that we use for the immersive simulations is Unity. This is a pretty well-known application platform that allows you to bring all of these virtual objects together and to build it in a way that an Oculus and HTC Vive or the like would be able to render and you can fully experience within this platform. Blender is a 3D modeling software, very powerful to use. It's free, and it allows you to really build out complex 3D models that you can actually use for your simulations. So a lot of the fencing, the VR simulation training application that we built, we had to build models within Blender to add for a more immersive experience. Third, here you see HoloLight. This is a software developer kit that we ended up implementing into Unity, which allows for remote rendering. And this allows us to bring the motive data into Unity, and then from Unity into the HoloLens 2, without really skipping a step, all in real time. And then lastly, we use Python for our data analysis. And so I wanted to give you a little bit of an overview of the technology before we kind of dive into how we use this technology for our approach in sports training. So I'm going to bring it back to Praneeth, and we'll take it from there. Thank you.
Thank you, Talis. So I'm going to continue my conversation with Rob. So Rob, I'm going to share with everyone some of the data that we've collected so far and our approach.
Okay.
All right. So first we captured the movements of experienced fencers. And do you want to talk a little bit about your experience when we did that?
Well, what we have here is our two former captains from the MIT fencing team who have not trained a huge amount because of the pandemic, but what we're doing is monitoring the motion of the point, the motion of the principal parts of the body. But what you don't see underneath the uniform are some EMG sensors, and then there are also force sensors in the shoes, and so we can measure what the impact is on the ground, but we can also figure out which foot is pushing when, which is releasing when. Look at the acceleration, look at the track.
You could slow down the videos. I don't know if that's helpful.
Well,
but,
yes.
And study it in more detail.
You can also speed it up. And, when we get further in the next phase of the discussion, we can talk about what we can do with that. But yes, we can slow it down. And the other is, and I mentioned this before, all this data is, as you can see in the graph, all this is locked together. So we don't have to sit there and guess what's happening when. We can figure out what the arm is doing, actually what the individual fingers are doing with the control of the weapon, and we can look at this locked into the motion.
Yeah, we get it about a 4 millisecond time resolution. So you can really slow it down and know exactly the time delays between how the different components of the body are moving with respect to each other.
Right.
Yeah, yeah.
And one thing that allows us to do that coaches can't see, and if you've got any athlete in a competitive situation is going to be self-aware, but not as self-aware as they could be if they were in almost a meditative state. We can now get information on things that the athletes themselves can't report back to us, and things that we can't necessarily see because we can't see the muscle contract. Mm-hmm. We can't feel the force on the ground. We can intuit it based on our knowledge as coaches, but we don't have the hard data.
Right, right. So for today, I'm going to focus on motion capture. And me, as somebody who has never fenced before, when I look at this, it looks very complicated. I don't know where to start. Right. So one strategy, if I wanted to learn fencing, was to ask experienced fencers to break down into simpler sequences. So before I get into that, I want to just show Aaron and Taylor here interacted for about 5 minutes. I'm going to speed that up and just show you a little animation of their trajectory interactions. So to me, this looks extremely complicated, and I don't know where I would start learning. Maybe an experienced eye could see much better. It's like maybe Taylor's tip is much further in compared to Aaron's. I don't know. But what we wanted to do to help beginner fencers was first capture a small sequence of movements. So here is Aaron doing, I don't know, I think I called it a disengaged lunge. I don't know if I used the technical terms, but it's just a 2 to 3 second video, and I just wanted to learn this sequence. Right, so normally what would happen, I would watch this video, I would come back, let me try to play with that, and if I had a foil or epee or a weapon, whatever weapon, I would try to use it in that manner, but there's no, I'm practicing out of memory basically. So one thing I wanted to see was, is there actually a difference in me practicing from memory and present and us developing all these technologies together? So we want to know if there's actually a difference when I put myself in these different situations. So we're going to talk about that a little bit. So here's me practicing, and I'm looking at my spine, the two specific muscles, erector spinae and latissimus dorsi, as I move, and I can monitor the trajectories of my shoulder, elbow, the foot, core, and the tip. So whatever you're interested in, you can put a marker there. And if you put several markers on big muscles, you can also understand the stretch contraction cycles. This goes back to the plyometric load stuff you were talking about. Right? So to assess the impact of immersive training on learning, we had 3 scenarios. So I was practicing after watching a video, practicing while watching a video on a 2D screen, and then I practice in VR. In the third one, I'm wearing a headset where I'm immersed in, it looks to me as if I am facing an opponent. So and now I want to know if my reactions are different in each of these scenarios. So if I switch to 3D trajectories over here, so here is the data that we bring into a different software, and these are the different markers that we monitored. And right now I'm plotting the tip of the 3D trajectory of the tip, and I do this several times. So and I can play it out, and I can see what that looks like. The orange is the saber, and all my movements, even though there's variance from trial to trial, it looks like they sort of have a shape. Right now, I'm none the wiser, but I'm just putting myself in a new situation where I practice in front of a 2D screen. So that's this purple trajectories. Now, I do this several times again, put myself into a 2D screen. The one thing, at least to my eyes, that pops out is that the starting position of the tip is very different when I practice from memory and when I'm seeing an opponent. Right? And the movement, at least to me, seems a little bit tighter. And finally, I'm going to put myself in VR and see how that compares. Right?
There's less variance in the tip motion.
In VR? Yeah. Yeah, all of these are with respect to my back foot. Right? Yeah, so even though it's a little bit tighter in on the 2D screen, it still expands out a little bit in VR. I was curious as to why that happened. So instead of looking at the tip, I wanted to look at the hilt. So the sequence was disengaged lunge, and when I see what the hilt is doing, if you look over here, I think this is a nice perspective. These are the trajectories of the hilt, how the hilt moves through space, and then I don't see much of a disengage when I practice in front of a 2D screen. Right? And in this case where I'm practicing by myself, I see somewhat of a disengage, but the tip is moving too far. It'll take too long. Right? In VR, it looks like there's a nice balance. So I'm somehow intuitively I've perceived a threat, and I'm disengaging and lunging.
Well, this is kind of a spoiler alert that we're going to get to when we get into the VR. But one of the things that you can see here is, because you're looking at the variation between the tip motion and the motion of the guard and motion of the arm, is that tells you something about the information you're sending to your opponent.
Mm-hmm.
When we look at this and we look at what we're doing, we also want to be aware of what the opponent is perceiving. And this is all data that the opponent is reacting to.
Right, exactly.
And this, knowing what we're sending as
Yeah.
a signal, gives us a lot more power as a fencer in terms of what we want to give.
Right,
Do we want to give, a signal, or do we want to give noise?
Right. We want to have some of the elements that are convincing them that I'm going to make an attack, but I won't. I turn that into something else. Is that my understanding?
That's part of it, but also it might be that if we're giving a signal with our hand first, we're giving a certain kind of information to our opponent, and then the tip is coming later.
Right.
Maybe for certain kinds of moves, this is what we want.
Right.
But for other movements, we want to give the tip motion first.
Right.
And that subtle difference
Right.
is something that we want the fencer to be able to get for themselves.
Right.
And we can keep working on it as coaches, but self-awareness in the fencer is really what we want.
Right. So to me, as of course, I had no idea I was doing any of this. Right. Yeah. Having looked at this data, I'm more encouraged to oh, cool! I didn't know I was doing that. Let me see what's happening in my body when I'm doing when I'm actually practicing.
Sure.
See if I can catch it with my awareness in the moment, so I have better control over my own movements.
And not only, but you also have more options. I mentioned that when we were discussing earlier. Let's say we have three velocity components to hit our opponent.
Mm-hmm.
And so we've got tip speed,
yeah,
we've got arm speed, and we've got core speed. And in right-of-way weapons, two of the three weapons, we want to initiate an action of threat, and we want to make our attack. So our tip has to do something first.
Right.
But then beyond that, it's up to us to decide what we're going to do with those three component velocities. And this allows us to be very precise in the measurement.
Right. So this is the trajectory of the core. I don't know if there's an ideal trajectory. I can't notice much of a difference, but certainly we haven't analyzed the data all the way.
No. Yeah, I mean, this is very, for people watching, this is very raw stuff.
Yeah.
We have not gone in to try and tease stuff out of this.
Right.
Yet.
Praneeth and Rob, just a quick question, the voice from above here.
Yes.
Is it true that you're sort of trying to teach as well the dynamics of the weapon so that you can get sort of the point to sort of lag what you're doing in some sense? Is that?
Do I want the point to lag?
No, I guess like in the coaching, is it you use the dynamics of the weapon to your advantage, the fact that it's flexible and okay.
Yeah. There are certain kinds of actions. There's the blade is flexible. There's a mass at the end, with the exception of saber. There's just the curve of the tip, so there's no switch at the end. But yes, you can work on the dynamics, and that's something we would like to study. We've got the trajectory, but we also can then measure the muscle contraction that's leading to that. Praneeth is looking at the motion here, but the thing I said before is we have a lot of data that we can overlay on this. We can look at the force applied through the floor. We can look at the muscle contraction in pretty minute detail. And then one thing that Tallis brought in that we haven't touched on, we'll touch on the end, is we can look at where the fencer looks, where they're gazing. Let's look ahead just a little bit. Once we have this data, when we talk more about, we are going to talk a little bit more about avatar creation.
Yes.
Okay. Then I'll bring that up once we talk about avatar creation.
Excellent.
But this is, there are like two phases in the analysis here, and what we're looking at is the first phase of the analysis.
Mm-hmm. We are going to do a little bit of a live. We're going to do a little bit of a live demonstration. So for this, we're going to show you somebody in a motion tracking suit using a saber. So what you see, a foil. So what you see on here are points that are being tracked live on the person that you're seeing in the background. And what Tallis is going to do right now is he's going to give real-time feedback of the position of the points to the person who is fencing to look at, so that they can look at their own movements. What you'll be seeing on the TV screen is the first-person view of the person wearing the headset. So you'll get to see what they are experiencing a little bit, and then you'll also get to see what they're doing right next. So those are the points that the person's wearing, and they can see them in front. Each dot represents one of those markers. And then, yeah, so as he moves around the tip, yeah, excellent. That's good. Can you tell that you're the one moving?
I can see the tip.
I know. The tip is a little off screen, but right now the point is to look at how your body is moving. Yeah. So we can obviously fine tune exactly what we show. And the goal of this is really to filter out information that is not relevant to a specific type of training and only show information that is relevant. And that, I think, really comes from the coaches.
And so here you would see the spine, and here's the right arm. And as he's projecting forward,
Do a lunge.
With a lunge, you can actually see that. And so now that we have this data, we can really add on some visualizations for the player to actually be able to see what they're doing. And we could talk about range of motion, distance, and all that kind of stuff, depending on what's important for the user.
Alternatively, I can bring it onto my face. And let's say I am a beginner fencer and I want to just see and an experienced fencer is wearing the suit, and I want to see how specific points on their body are moving. So as they move, so go ahead, make a move. Yeah, I can try to study just the relationships between specific points. Is the video clear, Talis?
Yep.
Okay. Okay, so these are a couple of ways in which we can use this augmented reality biofeedback system. And I'm going to switch back. Thank you for your brave participation. All right, so now Thales is going to talk a little bit more about a few different systems. So each of these systems has a different type of benefit. The immersive virtual reality system, the main benefit is to give them a realistic, give people learning a realistic experience so they can learn in under pressure or tension, if you will. And the purpose of the augmented reality system is just to focus on a specific move, just until you get it right. And we've tested it a little bit with other sports, and people who use it seem to really like it. And Thales is going to talk a little bit more about what he's going to do in this domain.
Right. So what you ended up all seeing was a 360 video capture of essentially taking the 360 video recording and assessing how they're just moving within the space. But if you wanted to take that one step forward, you can essentially build out a simulation for a little bit more of an active participation with the fencers. So more or less, it's not necessarily a video, but it's a simulation that has been designed specifically to monitor biofeedback within fencing. And so I'm going to show you just this little clip here that will actually, this is done in virtual reality. So what they're seeing is the virtual reality environment. And, no problem. And essentially we can build out models, and we can bring this out and actually develop a simulation training platform that will be pretty responsive with the person and the user within the experience. And so within this video here, we've essentially created a virtual reality simulation, if it works. And what we'll ultimately see is eye tracking. Just one second. No. And so eye tracking is very important in terms of this kinds of analysis, because we could really pinpoint exactly where they're looking and why that would be important. And maybe Rob can discuss why we might want to monitor the eye tracking of a certain player depending on what they're looking at.
So this is kind of the next step. We've got the data. We're creating an avatar, if you will, and we're feeding that avatar back in through the VR headset. Now we know what we're feeding in, and it's time locked. And then what we can do is put the same kind of monitoring devices on our fencer wearing the VR headset, and we can study how they react. We can see, let's say we start with the avatar moving at a moderate pace, something they're comfortable with, and we study what their reaction is, and we log this. Then we can raise the tempo. We can ultimately raise it up to approaching, depending on the scenario, we could raise it up to world-class tempo. And we want to do two things. We want to study how our fencer reacts to this. Do they change as the tempo goes up? Of course they're going to. Are they going to be changing appropriately? And then we also want to look at where they're looking. We're going to gaze track on them. We may find for certain athletes there's an ideal gaze track that they have, a map, if you will. And as the tempo goes up, under the stress, that tracking may go down along with other physiological responses. In certain high stress environments, they're talking about stress inoculation, and they do this to a certain degree in VR, but we want to kind of push it a little bit more. And as I say, we know what's going in, we know the phase locking for that, and we know we can monitor it. We want to see how they respond. That will help us then, with this information, how our athletes respond. That's data that we as coaches can then modify their training, figure out where their weaknesses, and move ahead from there. But with this adjustable tempo, this gives us some things that we can't get unless we could just basically, unzip a can and just keep pulling out Olympic level fencers and have our fencers fence against them.
Absolutely. Yeah, thank you. So if everyone can see my screen, hopefully it's displaying now. And this has been developed a little bit more to be an active participation. So hopefully if we get this working, what you'll end up seeing is an avatar actually playing the part of a fencer. We've developed this avatar actually pretty cleverly. We have a system called Lens Cloud, and this is a photogrammetry system that allows you to do some scanning of a real person, and we can get some really photorealistic textures and body captures, and we can actually take that and put that into a virtual environment. So instead of actually having to model the avatar themselves or ourselves, we can actually just scan them and place them into these environments. So I think we should be good now. Can everybody see the screen?
It's coming through. Yes. Perfect.
Awesome. So now I'm just going to press play here. And we have a couple things going on. We have the avatar in the center, and then we have some visualizations to the right here inside. We have a playback speed. So right now it is static, but you'll ultimately be able to alter how fast the avatar is moving. And right under there is a header called timers. And what this is assessing is how long a person is looking at that place within the avatar. So we have a head marker, a sword marker. You can't see them. They're embedded into the avatar, but this might give some visualization cues for the player or even the coach and allow you to really assess what you're looking at during the time. And on the left, you'll be able to change the moves that we were discussing that you saw previously. So if you wanted to do a little bit more of attack or defense, we can really monitor that and change things on the fly and to really assess how they're performing. And on top of that, let's see if I'll go to the next slide here. On top of that, we actually don't need to even rig the character or formulate the actions of the character in the 3D software. We can have our motive tracking system do that for us. And so this is a pretty awesome video here where we are transferring the data that we got from that motive tracking software into Unreal Engine. Unreal Engine is very similar to that of Unity. It's pretty similar in that sense. So we can actually take that and bring that right into Unity and use these movements to assess and to bring and to control the avatar, if you will, in the VR simulations. So if we wanted some real-time feedback, or we wanted to really understand the really small, minute changes that someone who is fencing is doing with maybe their legs or their arms, we can really capture that and formulate that into the virtual environment. That could really be pretty informative for everybody. Some things that we were thinking about were some haptic feedback as well. A lot of individuals were thinking, if you actually had an active simulation, can you feel the response from that virtual avatar? And so we're diving into kind of solutions to resolve that. So let's say the virtual avatar hits you in the leg. Would you actually be able to physically feel that? That's something we really want to get into place, as well as combine this with the EMG and the EKG to really understand the physiology behind these movements, as well as the eye tracking. So there could be all of these different components of biofeedback to really be encapsulated into this experience and to really bring it out lively and for the training module. So yeah, so I'm going to bring it back to Rob, and we're kind of going to go through the discussion. If you guys have any questions, we would love to hear them. And yeah, thank you all for joining.
I just wanted to make one comment about the haptic feedback suit. Praneeth was talking about one of the techniques used that he's gone through as a competitive dancer is that you sometimes will adjust the stance of another dancer, and this will make you aware of your own position. One of the things that we discovered scanning some of the fencers was some body alignment issues that we have been working on, but show up very much in the 3D scanning process. So one thing we might consider doing is with the VR and the haptic feedback, one thing we did not talk about is adjustable avatars, where a fencer can see their own avatar and see how they're standing and then reach in and adjust that avatar and then feel the haptic feedback in the suit. So then it's almost like, oh, I'm my own coach, I can adjust this. And that will give them more awareness. What we're hoping is that many athletes over time develop certain kinds of repetitive motion injuries, or they're not aware of destructive tension in the muscles. And we'd like to have them get in the feeling of, oh, I'm not doing this properly. I'm prone to injury. Or I'm coming back from an injury and the physical therapist has said, do this. All right, now I have to know what that feels like when the therapist is not there.
I'm gonna come back in here and to join the conversation. See me live. And so, Rob, thank you. That was wonderful and talented for me.
Oh, thank you.
So, I mean, I think there's the aspect for the coaching.
Yes.
How do you envision sort of using this as the athlete? Like, how do you, it's a tool that gives you the quantified information to maybe make it a little bit more quantifiable for you to then give guidance.
Well, I think
how difficult is it for the student to do that, or the person to do it themselves?
Well, if we have access to this information, we want them to have access to this information. And the thing that we talked about, where an athlete is watching the avatar and then getting their own feedback of how they react in certain stress situations, I think that's one of the main things we want them to do, is we want them to get this stress inoculation. And we want them to be aware of, oh, I start shifting my gaze when I shouldn't shift my gaze. And what we're talking about in terms of fencing can be applied to anything. I mean, an example I gave is, let's say you've got somebody who's a batter and they're in a hot streak, and you've recorded all their mechanics, and now they go into a slump, and you record what's going on in the slump. Then you can compare this two sets of mechanics, and you can give immediate feedback to the batter. Or you've got somebody who's really good with a free throw, and then they start missing. Well, maybe their gaze has shifted. You know, and it only takes that slight variation in the gaze under the pressure of competition to make someone miss. So any of these techniques are not just fencing oriented.
Just to add to that a little bit, so to summarize, what our hope is we could cover an observation gap for coaches and an awareness gap for athletes.
Yes.
An observation gap meaning we can provide tools whereby you can look at the same thing in very different ways and parse it out, and then that will also help communicate with the athletes better. And for the awareness gap, all the tools we are saying is, oh, I think I'm doing something, but I wasn't actually doing that. My coach said it, I think I'm doing it. Why is my coach repeating the same thing? I've encountered this problem many a time in dancing.
And one of the exciting things, I think, these tools, quite frankly, have been around for a long time, but only accessible to Major League Baseball or the NBA, sort of the sports that had the big dollars and sports or teams that had big dollars. And certainly, having a facility like this and doing the full motion capture gives us a platform to engage with the university, but also the types of approaches are not that far away from being deployed on a few cell phones. Like you can do motion capture quite well mobilely.
Mm-hmm.
Right? So there's the pristine premiere of what you can do in the Immersion Lab. There were some questions along how does this get deployed? And so the technologies are now available or at the cusp of being available, so we can take the learnings and the approach and not just have to be in the Immersion Lab, but actually be with your phones and your iPads out in the field or out on in the arena of where you practice your sport.
Mm-hmm. Mm-hmm.
Can't see if we have any questions there.
I'm going to open up the chat.
So how are we doing in time? Good. We'll take a few questions from the audience.
This is pretty cool. Is this monitoring technique applicable to improve technique on playing musical instruments, piano or keyboards? Could you repeat the question?
So the question was, could these techniques be used for playing an instrument, whether it be motion tracking for piano or I think that was the piano. Short answer is yes. I'm not a piano player myself, so I can't speak as a piano player. But I guess you can imagine these tools being used in some way, right, with various levels of success. Any time that you're trying to teach repetitive motion and to quantify the motion and how to move your body, and whether that be happening at the scale of your spine or happening at the scale of your fingers, the same technologies, different form factors, different resolutions that you would need for those different things would certainly be very relevant.
Are you looking for high school teams to test on?
Interesting question. So you send us an email, immersed@mit.edu.
We'll put up a slide.
Yep, we'll put up a slide at the end. But certainly, the Immersion Lab, as Rob now well knows, is a shared and central facility on MIT's campus. But we don't just support the MIT campus. We're open to the community. It's a little bit easier to use us if you're proximal to us, but we have tools for both data visualization and data processing that might also be applicable. But we want to support the community, understand the needs, figure out the things that are the research questions as well, that we can work to support and sponsor for our students and our investigators.
Do you have a video of a session with an avatar that you can show? Not yet.
So the question is, do we have a video with an avatar that we can show? That's in process. So stay tuned on the Immersed webpage. So we'll continue to post assets and stories there. So I think we're probably good on time to give people a little bit of time at the hour. Unless there's one last question, Praneeth, that you want to pull up.
How can someone help or contribute to this project?
How can somebody help and contribute to this project? So certainly we have reach out to us. But if you're interested in fencing, you certainly reach out to Rob. We'd love to hear from more fencing coaches. Understand, Rob has I think a phenomenally forward-looking vision for how to do this with our student athletes. We need to impedance match to both the individual athletes, but also to the individual coaches. Coaches are going to use this in different ways. They have different styles, and would love to have that community and support Rob in engaging in that conversation. And Rob's been very good in reaching out to the other coaches at MIT. And we started this, if you think back, so Rob reached out to us just after our baseball session with MIT coaches there. So would love to talk with additional sports. And that recording is indeed available if you're interested in the baseball. But so I think with that, another question? 2 more minutes?
Yeah.
Okay.
This is really great stuff. What would be required to implement something like this in a club? Hardware, software, money?
Yeah, so how would you implement this in the club? So hardware, software, money, yes, people. And depending on the fidelity of what you needed, you could do some of the motion capture with your mobile devices on tripods. And there are portable versions of what we have here available. I think and then certainly the younger generation is increasingly familiar from gaming and just what's available. We have the staff. You tap into your students, tap into the youth to know how to deploy the technologies. But we're here to help as well. We have our youths here to help.
Can this be used to review live competition footage after the fact?
Can we use this for live competition footage after the fact? So if it were recorded, if we had 3D capture during the competition, maybe we can turn it over to Rob. Would that be something that would be interesting to do? I mean, maybe we do a mock competition.
I think it would be easier. I think we'd have to definitely try it in a mock competition. Maybe during a varsity practice or that kind of thing. There is going to be a lot of data that comes out of that. So data storage is going to be a big deal, and there's going to be there's some periods where there's motion back and forth, and it's valuable, but we might want to drop some of that. I think the short answer is yes, we could try to do that. We would have to make sure that the sensors, the markers that you saw, were in a position where they're not going to be damaged by the impact of the weapon. And also, I think you might have noticed that parts of the guard are blacked out, and that is an infrared issue. Yes, with modification, I'm sure we could come up with something. I mean, one of the things we're trying to do is order in some equipment that is dedicated to this fencing project.
Right. And you bring up another good point that I'll use as a closing comment. So on the data side, so I like to describe the Immersion Lab as being the data interface to MIT.nano. And that means a couple different things. It means having AR and VR capabilities to visualize data on big screens, to visualize data, capture, motion capture, but also as we collect data on many athletes for many athletes on different events and different sports and different types of modalities of doing this, we do expect big data to happen, right? Mm-hmm. Just you can't do data anymore without it being big. So there is that data analytics piece. There's the thing that you can do for the individual, and then there's the thing that you can learn by looking at a population of individuals, and that's where being able to collect this data with several teams, whether it be at MIT or student athletes in high schools, would be a very exciting opportunity for us as well in looking at the next steps of the data analytics that come after this.
So please reach out to us.
Yeah, so please, we have immersion at MIT.edu. And I want to thank you again, Rob. Wonderful. Thanks for reaching out at the very beginning and doing all this experimentation, leading this conversation. Praneeth and Talis, always a pleasure. Friends, please stay tuned for the next Immersed and have a good day. Thank you. Stay safe.